Okay, good afternoon. Let's continue our lesson. So, unfortunately, dalawang Monday na tayo hindi napag-meet. That's why I'll just give you a recorded discussion on errors. Okay? Para by next meeting, lahi na topic atong ma-discuss. Okay? So, to continue, we are now on the residual or deviations. So when we say residual, it is defined as the difference between any measured value of a quantity and its most probable value. So kumbaga that is the change, between your measured quantity from the most probable value or MVP. So if you are going to compare your quantity to the MPB, uh, that's the residual. No? Okay, then we have here the probable error, which is the quantity which, when added to and subtracted from the most probable value or MPB, defines a range, no, within which there is a 50% chance that the true value of the measured quantity lies inside the limits that you had set. Or kumbaga, MPB plus or minus PE or probable error. So that would define the range of your measured quantity. So let's say you had a measured value of 100 mpb of 120 meters, no? And then you computed a probable error of 0.02 cm, 0.02 meters. So the actual value of your measured quantity would be 120 plus or minus 0.02. So that's the range of the true value of that quantity. Okay. So the probable error defines a range, no, or limits of the true measured quantity. So in getting the probable error, we have the following formula. First is for a single measurement. So it can be computed that plus or minus 0.674489, the square root of the sum of the square of the summation of the residual divided by n minus 1, where n is the number of observations. So yung PE mo ngayon, siya na yung magbibigay sa'yo ng limit. Okay? Okay, then we also have here the probable error of the mean can also be computed using the following formula. So halos same formula lang sa single, but na dungag na isa ka variable n multiplied by n minus 1. Okay? So kung single, wala yung n. Kapag the mean, you need to multiply the denominator by the number of observations. So we have here the definition of the variables. Okay, just go through with the presentation. Then we have the relative error or the relative precision, which is the ratio of the probable error and the most probable value. So it will determine how precise your measured quantity. Okay, so sometimes there's the wherein you are required to determine the final result, which is often affected when a computation involves quantities that are subject to accidental errors. So we have here the two applied Prince theory of errors. Number one is the summation of errors and the product of errors. So for summation of errors, if several measured quantities are added, so each of which is affected by accidental errors, the probable error of the sum is given by the squares of the separate probable errors arising from several sources. So kumbaga, it came from probable error of each measurement if you had different measurement. We also have here the product of errors for measured quantity, which is determined as the product of two independently measured quantities, such as let's say quantity 1 and quantity 2. The probable error of the product is given by the following formula. Okay, so let's say from quantity 1 multiplied by the probable error 1. I think there's something wrong in the formula. It should be the probable error number 2, and then for quantity 2 multiplied by the probable error 1. Okay, it should be a cross product of two errors. Okay, okay, let's try this example number 5. So the following values were determined in a series of tape measurements of a line that is 1000.58, 1000.40, 1000.38, 1000.48, 1000.40, and 1000.46. So determine the following. Letter A, the MPB of the measured line. B is the probable errors of single measurement and the probable error of the mean. C is the final expression for the most probable length. And D is the relative precision of the measurement. Okay, to get for the MPB, we just get the average of the following measurements. So dividing, getting the average, it would give us a value of MPB of 1000.45. So in getting the probable errors, so we need to compute for each uh, residual or the V of the measured quantity. So to compute for each residual, for number 1, 1000.58 minus the MPB of 1000.45 would give us a 0.13 value, which is positive. Okay, and for next value is 1000.40 minus 1000.45. That would give us a negative 0.05, and the rest kamo na bahalag compute. And then kuha na to ang total the measured quantity, that is 6002.7, and total of the residual is 0. Then we need to compute for the square of the residual, no, para sa ating formula. So for first quantity, the square of 0.13 would be 0.0169. So now we already computed the square of the residual, and the total residual is 0.0278. Now using this following formula, in order to compute for the probable errors of each single measurement, we'll just use this equation PES. Okay, to get for the PS, that is 0.674489, the square of 0.0278 divided by number of observation is 6 minus 1. That would give us a value of 0.05. Okay, so that is plus or minus 0.05, and same through with the mean probable errors. So using this formula would give us a plus or minus 0.02 meters. So therefore, for the letter C, the final expression for the most probable length would be 1000.45 plus or minus 0.02. So mo na siya ang iyahang range, no. So it pwede siya mo taas og 0.02, pero pwede siya mo baba og 0.02. So meaning mo na siya ang probable, no, true or actual measured quantity. Okay, so this means that there is a 50% chance that the true distance falls between 1000.43 to 1000.47, and also a 50% chance that the true distance lies beyond that range. No? Okay. And for letter D, relative precision of the measurements, that's the ratio of the probable error to the MPB. And for the single relative precision of each measurement, that would be 0.05 divided by 1000.45. It would give us a 1 over 20,000, and the relative precision of the mean would be 0.02 divided by 1045, would give us a precision of 1 over 50,000. Okay, so nakuha. Okay, so let's continue. We are now on the weighted observation. So measurements are usually done on various conditions, right? Such that measurements have different degrees of reliability, and thus the weight are assigned to each measurement before the most probable value is computed. Okay, the assignment of the weight to different is usually based on the judgment of the surveyor, the number of measurements taken for a particular measurement, and the assumption that weight is inversely proportional to the square of the probable error for the said measurement. Kumbaga, let's say na ay duha ka group, no? May dalawang group na nag-measure of the same quantity. Let's say group 1 measured a quantity in 2 repetitions versus group 2. Let's say they conducted 4 repetitions. So if we are going to apply the weighted observations, it means that the measurement of group 2 is twice more reliable than group 1 because of the weights, no? Or because of the repetitions they conducted. Okay. So in dealing with the weighted observations, we have the following formula of the MPB, where X is the measured quantity of individual observations multiplied by its responding weights divided by the number of observations. Okay. Okay, so to apply the formula, we have here the following example. So four measurements of a distance were recorded as 284.18, 284.19, 284.22, and 284.20 meters, and given weights of 1, 3, 2, and 4 respectively. So determine the most probable value of the distance. So remember katong previous nato na example, no, we assume that the measured quantity is correct, no, without error. So that's why we immediately computed its average, no, without considering the weights of each measurement. Okay. Okay, so for this solution, let's rewrite each observation. We have here 284.18, 284.19, 284.22, 284.20, and now it has a weights, no, of each observation. So for 284 na ay 1, 3, 2, and 4. Okay, now we are required to determine the most probable value of the distance. So applying this formula, we just need to multiply the observed quantity times its weight to get the most probable value. So therefore, for P. So 284 times 18, that will give us 284.18. Okay, then 284.19 times 3 would give us 852.57. So 284.92 times 2, that is 568.44. Then 284.2 times 4, that would give us 1136.8. Okay, getting their total or sum, that is 4, that is 10. Okay, here total is 284, 2841.99. Okay, so applying this formula, we need to get the sum divided by the number of observations. So therefore, the MPB, the weighted mean or the weighted MPB of this quantity, that is 2141.99 divided by the number of observations n, that is 10. That would give us a value of 284.2 meters. Okay, so another problem is desired to determine the most probable value of an angle which has been measured at different times by different observers. The values observed were as follows. So we have the following angle. We have 74 degrees 39 minutes 49 minutes, which is measured 2 times. Also have 74 degrees 39 minutes and 27 seconds, which is measured 4 times. And 74 degrees 39 minutes 35 seconds, which is measured 6 times. So if you will notice, given ang iyahang corresponding weights of each observations. Okay, so same lang sa atong gibuhat ganina. We'll just get the product of the quantity by its weight, no? So getting the product will give us the following quantities. So will give us this computation. So get the sum. So the MPB or the weighted mean using the formula of MPB. So the total sum of the product, that is 895 degrees 54 minutes 48 minutes divided by 12 would give us a MPB. So 74 degrees 39 minutes and 34 seconds. Okay. Okay, lines of travels to establish the elevation of a point are run over 4 different routes. The observed elevations of the point with the probable values are given below. So determine the most probable value of the elevation. So please take note. So we have here the following observations, and also given is their probable uh, errors or probable value of each quantity or observations. Okay, so for our procedure, so since given ang PE, we need to compute for the square of each PE. So para magamit natin yung formula na the weight is inversely proportional to the square of the probable error of the measurement. Okay, so just compute for the square of the probable error. So 0.006 square is 0.00036. Okay, then we get the weight, which is inversely proportional to the square of the probable error, W. So 1 divided by 0.0036, that is 27,778. So to get for the relative weight, so mag-base ta kung saan yung pinaka lowest or pinaka maliit, no, na quantity. So in this case, we can say that the 1736 is weight 1 since siya ang pinaka mababa. So therefore, 27,778 divided by 1736 would give us an approximate 16 weights. So 6944 divided by 1736 would give us approximate 4 and then 1.78. And then let's compute for the product of the observed quantity, that is 200 209.832 times the weights. That would give us 3,517.312. Then sa next is 879.720, and then 391.068, and then 220.021. Okay, and then let's get for their sum, compute for the sum of the product. So that is draw 5,008.121, and the total number of observations by weight is 22.78. Okay, so therefore in computing the MPB, or the weighted mean, MPB by weights, so we just divide the ratio, okay, of 5,008.121 divided by the observation 22.78. So it would give us MPB, or the weighted mean, that is 209.847 meters. That is the most probable value of the deviation of the point. So another example, we have the three sides of triangular shape tract of land is given by the following measurements and corresponding probable errors. So one side is 162.54 plus or minus 0.03. Another side is 234.25 plus or minus 0.05, and 195.7 plus or minus 0.04. So determine the most probable error of the sum and the most probable value of the perimeter. So we have here an individual observations of each sides, so we know that the perimeter is just the summation of the sides. Okay, so going back, we will just use the probable error of the sum formula here, so here we get to compute for the square of each probable error. So the probable error of the sum, so for 1, so that is plus or minus PE of 1 is 0.03 square, plus PE2, that is 0.05 square, plus the third side is 0.04 square, then we got the sum of all the probable error, then get the square root, that would give us a probable error of the sum, that is 0.07 meters. And then to get the most probable value of the perimeter, so let's just compute for the perimeter, that is 162.54 plus 234.25 plus 195.7 would give us a value of 592.5 meters. Okay, so for the final we can say that the perimeter would be expressed as 592.55 plus or minus 0.03. meters. So therefore, the range could be 592.43 and 592.57. So that's the range of the true length of the perimeter. Okay. So now it's time for you to compute for your assignment, solve for assignment with the following problems. No? Need to compute uh, these two problem. Okay, to be submitted next meeting on Friday. Okay, so that's all now. So for next meeting, we will start discussing on a new topic. Okay, so that's all for today, and thank you.